So in example 5, we're looking at the same density function that we had in example 4. F of y is 1/2 times 2 minus y on the range from 0 to 2, and it's 0 everywhere else. And we want to find the variance. So let me remind you of the useful way to calculate the variance. The variance is e of y squared minus e of y quantity squared. And so what we'll do first is we'll calculate e of y squared, and then we'll come back and we'll plug it into this formula. So e of y squared by itself here, I'm not calculating the whole variance yet, I'm just finding e of y squared. So by definition, that's the integral from negative infinity to infinity of y squared times whatever density function we have for this variable. And so in this case, our density function is 0 everywhere outside the range of 0 to 2. So I just need to integrate from 0 to 2. Y squared, and now I'll look at that density function, is 1/2 times 2 minus y dy. So that's the integral from 0 to 2. If I distribute that y squared and the 1/2, y squared times 1/2 times 2 is just y squared. And then y squared times 1/2 times y is 1/2 y cubed. And I have to integrate all of that with respect to y. So my integral is y squared integrates to y cubed over 3. Now y cubed integrates to y to the 4th over 4, but I've also got a half here, so I'll have to make that y to the 4th over 8. And I want to integrate all of that from 0 to 2. Y equals 0 to y equals, no, not y equals 2. And so I'll get y cubed over 3, that's 8/3, minus y to the 4th over 8, that's 16/8. And if I plug in 0, nothing happens there, so I don't need to worry about that. That's 8/3 minus 2. 2 is 6/3. So the expected value of y squared is just 2/3. Now, that's not the answer to the problem yet. We were supposed to find the variance, and the expected value of y squared is just one step in finding the variance. Here's the rest of it. E of y squared is 2/3. We just calculated that. Now, the expected value of y, I would have to do another whole calculation to find that. But I did that calculation in example 4. Hopefully you did it with me. If you haven't just watched example 4, now is the time when we're using the answer. So e of y, it actually came out to be the same thing. It was 2/3. It is 2/3 by example 4. That's really a coincidence, the fact that that came out to be the same as e of y squared. I wouldn't put too much stock in the fact that those numbers came out to be the same. That's not going to happen usually. There's no sort of deep property that made those the same. It's just the way that the integrals worked out. So this is 2/3 minus e of y squared. So minus 2/3 squared. Minus 2/3 squared. So this is 2/3 minus 4/9. And 2/3 is 6/9. Multiply top and bottom by 3 minus 4/9. And I finally get my answer here for the variance is 2/9. The variance of this random variable. So in case you're a little fuzzy on any of the steps, let's check those out again. My generic formula for the variance is always e of y squared minus e of y quantity squared. The e of y by itself, I figured out in example 4. You can go back and see the video in example 4 where that came from. We figured out that it was 2/3, so that's where I dropped that in for e of y. This e of y squared takes more work. E of y squared, we actually have to calculate that using an integral of y squared times the density function. So I put in y squared, I put in the density function that came from right here, and these bounds from 0 to 2, that came from these limits right here, because everywhere else the density function is 0, so I really only need to do my integral from 0 to 2. Once I've got it in that form, it's relatively easy algebra to distribute the terms, to do the calculus there. It's just the power rule, drop in the limits 0 and 2, and simplify it down to 2/3. So that's 2/3 gives me that 2/3 for e of y squared. The other 2/3 came from e of y. That was from example 4. Really a coincidence that those numbers were both 2/3. That's not any deep property manifesting itself here, so don't read too much into that. Those could easily have been different numbers. Now I just simplify the fractions. 2/3 minus 4/9 simplifies down to 2/9. That's my variance for that random variable. So that wraps up this lecture on mean and variance for continuous distributions. This is part of the chapter on continuous probability, which is part of our larger lecture series on probability. So you are watching the probability lectures here on Educator.com with your host, Will Murray. Thanks very much for joining me today. Bye-bye.